we are taking derivatives, and in this particular one here we're going to be taking the derivative of an inverse trig function, and it happens to be cosine. So this ARC right here means arc cosine, and means that we're taking the inverse. There is another notation I think I introduced somewhere, that notation for our cosine. But anyway, this is going to be the formula here that we use to find the derivative of the inverse, and this d over dx means, okay, we're going to be taking the derivative of this function here with respect to x, just in case if there was any other variables in here. Alright, so here we go. So this right here, this u prime, this is our u, so we want to take the derivative of this. So I've identified u as x over 2, and taking the derivative of u, you get 1/2. So the derivative of this is 1/2. So now what we're going to do is just take this and plug it directly in right here. So our u prime goes here, and then u, which is x over 2, goes here. Don't forget the 3. Alright, we got the 3 out in front of the arc cosine, and then I just bring the negative out here. Alright, and then we want to simplify. Seems like that's mostly what we do in calculus, is a bunch of algebra, but want to simplify this. I went ahead and squared the x over 2. This just becomes x squared, and then to the 4. Got a common denominator here, or you can think of cross multiplying. 4 times 1 is 4. Alright, so 4 minus x squared over 4. And went ahead and took this 2, multiplied it by the half up here, and got 3/2. Then what I did was I took the square root of the 4 minus x squared, and took the square root of 4, and square root of 4 is 2. So I just kind of broke this up, took the square root of the numerator, square root of the denominator. And then did a little flipping going on here, and to simplify this down. So you should be able to go from here to here on how I got that. Anyway, so we end up with 3 over the square root of 4 minus x squared with the minus sign out here. Okay, so we have h of t is equal to arc sine t squared. And what we're going to want to do here is take the derivative. We want to find h prime of t. So here's the formula here that we're going to use for doing that. And so we want to identify what our u is, and our u is the t squared. Then we're going to take the derivative, so u prime is 2t, and then once we get this, all we're going to do is just plug it directly in. So the 2t goes in for u prime, so that gives me 2t up here in the numerator, and then the t squared goes in right here where the u's at, so that becomes t squared squared, which will end up being t to the 4th. And therefore we get h prime of t is equal to 2t over the square root of 1 minus t to the 4th. Alright, let's look at another one here. We've got k of t is equal to t times t to the negative 1 of t. Okay, so this was that other alternative notation that we use. I seem to find this just a whole lot easier to look at than that arc cosine stuff. But this same thing, it's the inverse of tan. I mean, I could have arc tan out here, but instead I wrote it as an alternative type of a notation. So basically what we've got here is two separate functions. We're going to take do the product rule thing. But let's look at the general notation here for finding the derivative, letting u be some function inside. So all we do this time is we take the derivative. We got u prime over 1 plus u squared. So we've identified our u as t, and then there's t prime, the derivative of t is 1. So that would be then just plugging the stuff in right here. But what we're going to have to do in this problem is do the product rule. So we're going to take the derivative of the first function times, and rewrite the second function, plus our first function times the derivative of the second function, right? This is the product rule. So we take t, plug it in for right here, right? And u prime goes up here on top. And of course we've got to simplify this down. And pretty self-explanatory, t times 1 is t, and there. So that's it.